Right, so let's look at example number 2 now. So again, the first step that we need to do is we need to factor the denominators and numerators. So this doesn't change, obviously, the first rational expression. Our second one, however, we can see that we have two terms separated by subtraction. Both are perfect squares, so we know that it's a difference of square. So we end up with 2x plus 1, x minus 1. Now I need to determine what my common denominator is going to be. So we can see the first one has an x plus 1, so I know I have to have an x plus 1 for my denominator. When I look at my second one, it already has an x plus 1, so that's fine, but I also then will need an x minus 1. So my common denominator is going to be x plus 1 times x minus 1. So again, that becomes my denominator for the question. And we end up with x. What do I multiply x plus 1 to get my new denominator? Obviously, it's x minus 1. And the last one is stays at 2. Now, one thing I didn't do in the second, well, actually in the first step, is I didn't state the restrictions. I thought about them, but I didn't state them. So there that is. So now it's just a matter now of expanding the numerator. Okay, don't start canceling, because if you start canceling, you're just going to go back to where you were. Plus, you cannot cancel anything like this x minus 1 can't be ripped apart from the plus 2 because you're adding there. So let's go here and we'll expand. So we end up with an x squared minus an x plus 2 all over x plus 1, x minus 1. Again, I attempt to factor two numbers that multiply to give me 2, but add to give me negative 1. Looks like you can do it, however, we are finished because it doesn't. And finally, then we have to put our restrictions at the end. And one more example. Okay, so when we look at this one, same kind of process. First of all, we need to factor numerators and denominators. So again, if you notice, again, we have a difference of squares. Notice that comes up quite a bit, actually. And, oh, sorry, that's a take away. X plus 4 over x plus 2. Again, I need to come up with my common denominator. I can see that my first one has an x minus 2 and an x plus 2, and my last one has an x plus 2, which is already covered here. So this is our common denominator of x minus 2, x plus 2, and our 4x does not get multiplied by anything because it is the denominator. And then we're subtracting. Now we're subtracting this whole numerator. So I'm going to put that numerator in a bracket. And my new denominator means that I'm going to have to multiply this by x minus 2. Okay, again, almost finished. And you should have noticed already that I didn't put the restrictions yet. Now, it's totally up to you how many steps you do in order to expand this. Okay, so I know I have an x squared, so it's going to be a negative x squared. I have a positive 4 and a negative 2, so I have a positive 2 multiplied by the negative, so I have a negative 2x, a negative 8, so it's going to be a positive 8. And if you didn't get that, you can expand that out the long way if you so wish. Gather like terms, negative x squared plus 2x plus 8 all over x minus 2, x plus 2. Again, I'm going to factor out a negative out of that numerator just so I have a better idea of what's going on there, because it's possible we could factor that. And if we look at it now, we can see that we have two numbers that multiply to give me 8, subtract to give me 2. The largest is negative. Well, 4 times 2 is 8, and if I subtract 4 and 2, I get the number 2. So actually that could be factored. So we would have negative bracket x minus 4, x plus 2, all over x minus 2, x plus 2. And you can see this is an example where actually by factoring the numerator, at the end we end up that we do have a factor that we can cancel out. And this is our final answer. And again, I didn't state restrictions, but I have to make sure that I'm going back to the beginning where I first factored. And so x cannot equal plus or minus 2. And so that means I have to add that as well. Okay, so that's the end of 2.2. Have fun with some questions.